All right, so I thought I'd start off with the motivations behind this talk. And they tend to be that I write bad code and I constantly bear the consequences of badly written code. And I think this is a somewhat relatable situation for most programmers. And I think, for example, if you catch yourself saying, like, trying to make a simple change and then it actually becomes more complicated than you thought, or you tried to change an area of your code and then it caused another area of your code to fail, you're probably in a similar situation to me, where you run into these bugs and you just think, oh, if I had just written that better a long time ago, then I wouldn't be running into this super duper frustrating situation. And if you try to follow that trail down to writing better code, you end up being given a lot of metrics. These include modularity, the solid principles, cyclomatic complexity. And the thing is that you have a few issues. One is that you don't really know how to achieve these metrics. And secondly, you don't really know how to organize a trade-off between these two things. So if you have an option A and an option B, and they give you different values in this metric, you don't know how to do the trade-off. And if you look a little bit further, you start looking into design patterns. And there are a billion design patterns, and some of them can be used together, some of them can't be used together. And if you ask somebody, how do I pick a design pattern, it really heavily depends on your situation. And often, in 6 months' time, you're just like, oh, shit, I obviously should have picked this other design pattern, but how could you possibly know that at the time that you were writing the code? And I consider this to be heavily a top-down approach to sort of solving your problems, where you have this incredibly complex domain, and you are trying to evaluate your solutions in that incredibly complex domain. And this is a very important skill. This is your job, right? Your job is to have intuitions about your domain, run some experiments, see whether that's true or false, and then go from there. But the issue is that it's very, very hard to come up with very deep conclusions about what you're doing, because these two domains just are so different. And so another way you can look at things is from a bottom-up point of view, where you look at very, very small fundamentals, and you can draw deep conclusions about these fundamentals that won't change that much between the domains. And so while both of these skills are important, in this talk I'll be focusing on a single fundamental thing, and that is if statements. So when you see an if statement in your code, can you answer the following questions? What problems is the if statement causing? How do I remove it? How do I solve any follow-up issues after removing it? And is it even worth removing at all? And I've written some vague answers on the right here, but I'll be going into that in a bit more detail throughout this talk. But what you'll notice is that there are quite a few diagrams around here, and so they're not very complicated diagrams, but I'll just go over what those diagrams actually mean before I begin the talk. So the first concept is this idea of functions as arrows. So this diagram is representing the double function. It takes integer as an input, and it takes integer as an output. And you can see the code over here. If you have two input parameters, you can represent that as a function from a tuple to a regular type. If you want to mutate state, you can be like, oh, OK, that's just a function from an animal to a completely new animal, where the animal is no longer hungry. And you can chain these functions together. So if you have a double function and a two-string function, you can create double then two-string using the code on the left. And this is intuitively true for all functions. As long as they have the same input and the same output, you can match them together and create a bigger function. The second type of diagram I'll be showing is types as sets. So essentially what I'm saying is, if I say x is an integer, I'm saying x is one of the values listed in this infinitely long list here. Same with y as a string. Y is one of the values in this infinitely long list here. And with sets, you can say a function is really just a mapping between these two sets. So I can say, hey, every single one of these things on the left has an arrow coming out of it, and it follows to a value on the right. Some of these values on the right are achievable. Some of these values are not achievable. So when you see these diagrams throughout the talks, that's what they mean. It shouldn't be too complicated on that front. But I'll be using those diagrams everywhere. So now that we have the diagrams out of the way, let's have a look at the first question, which is what problems are if statements causing? And I want to go through an example. Oh, that's my face. And this is like trying to do some pricing software for a vet. And so often these projects start very, very simple, where you have an animal and you might have some sort of bill that your function outputs. And then you can write a very, very simple function that takes the animal, gives you a base price, and then also gives you some price depending on the weight of the animal, because you might need more dosage for that particular animal. But as things get a little bit more complicated, you start adding a little bit more functionality. So in this case, you find out that, hey, actually, we want to charge different prices for dogs. So let's add a function in here that adds an additional cost charge for your dog. And it gets a little bit more complicated. You've added an if statement here. This entire function is effectively an if statement because it returns 0. And as things get more complicated, you end up with more and more animals and more things that you have to do. And you might want to include a vaccination bill and a desexing bill or something equivalent. And the issue is that from the outside, when you're calling this function, you just have a billion questions to answer. Will I have a vaccination bill or not? If I look at the function signature, I can see that this returns a nullable. So some of the time I call this function and I get a bill, some of the time I don't. Some of the time I call this function, I get a bill, and sometimes I don't. Like, inside of here, if you look into this code, actually sneakily I've added a like days of recovery time. That's just something that happened while the scope of my problem became more and more difficult. But actually, will I have that property or not? It's nullable. Will I have a days of recovery time or not? And the thing is that actually it just turns out that only dogs really have this recovery time, and no other animal, we don't bother trying to estimate the recovery time of any other animal. We have things like, what are valid animal values for an animal? Can my cat have wings? Can my dog's weight be negative? Can my bird have whiskers? And whenever you're creating an instance of an animal, you do have to give it data, right? But you don't know which data you actually want to put into your class and which data you don't want to put into the class. And this is a classic example of exponential growth, because your list of questions becomes longer, but also the amount of code that you have to read through to understand what's going on also becomes longer. And if we start looking through this, actually this code just has a bunch of traps in it. Rats don't return a vaccination bill. What happens if my gender is ASDF? What does that mean? Should it be considered a female dog, or should we consider that a bug? What happens if my weight is negative? My bill might be a negative bill. What happens if my cat, I'm trying to get a desex bill for my cat, and it's neither male or female? What happens if I use lowercase m for my male? I'm going to throw an exception. This is going to blow up my program. These are all things that you have to consider, and it's a big problem, and this is what technical debt spawns from all of these complicated if statements. And if you forget to ask any of these questions, you just create bugs. And so I've got a summary of what that means at a high level. Okay. I have no idea where I am. Here. Where you have this type animal, and you have functions from the animal to our individual bills, but we have a ton of technical debt building up. We have useless information, we have increased assumed knowledge, we have no handling of invalid state, and we have repeat logic, where we're constantly working out that my animal is a cat for both this function, and maybe in the internals of these functions. And so what this leads to is a situation where you have your function, but the only way to really think about it is to go in and be like, oh, I need to avoid the landmines in this function. Let's read 1,000 lines of code, 10,000 lines of code. Over and over again, this is going to grow as your application gets more complicated. And so you have to add these warning signs, some comments that are like, oh, just be careful. Don't actually use this function if you're using it with these values. And this gets worse and worse and worse, because your application is built out of functions using functions using functions using functions using functions. So if I'm using this function over here, I have to dive into the functions that it uses and the functions that that uses and so on. And if it turns out that there's a landmine in here, I just have to scour through millions of lines of code to figure out what the hell's going on. And so this is the case I'm presenting for what if statements cause, is that you end up with these very, very large composite types that you just don't give you very much information about what's going on when you look at the function from the outside. And so with that as the problem, let's look at a solution. And I think a lot of you will think of this as an intuitive solution, is that your animal type can be split into dogs and cats and rabbits and birds. So this is an example of what the getDsexBill function looks like beforehand. But if you split it into separate types, what you end up with is 4 separate functions, all with very, very simple and easy to understand type signatures. And what you also notice is that there's no need for us to return a nullable anymore, because we're not actually handling the things that are invalid inputs as inputs at all in any of these functions. So we can look at what that looks like in this code sample. And so we have a dog, we have some sort of strut which represents a positive double, so we don't have to handle negative weights. We use an enum for gender, so we don't have to handle all of the weird use cases of that. And we notice that cat has less properties than dog, and rat has no properties at all, because we don't care about any of the properties. We don't care about a rat's weight. We don't care about a rat's gender. And so if we look through here, we can see these individual functions have become a lot more small, and you can actually understand what's going on if you do actually need to look into these functions. So we've gained quite a lot from just splitting this animal type, this composite type, into a whole lot of smaller types, each representing like a distinct sort of part of this set here. Like nothing in the dog type is representable as a cat. So some things we've added are less assumed knowledge. We don't care, like it's obvious that we don't care that about a rat's age. Like validation, we don't have to validate like negative weights. We don't have to worry about it. Less potential outputs. We don't have to think, look at this function and be like, what the heck is this going to do? And we don't have to handle nulls, which is probably one of the biggest upsides, is that, hey, I don't have to think about all of these failure cases because the function just won't take in a failure case. And so the sort of high-level takeaway where you extract away the problem that we're currently looking at is that any if statement can be removed by splitting one type into 2 types. So, and this is very easily provable, right? You can just think of a function with an if statement and then get all of the values in that set and say, hey, they're all, like, the values that are true, we'll put that into one function. The values that are false, we'll put it into the other function. We'll define 2 separate types, one called input type when true, one called input type when false, and we suddenly have 2 functions. And this is like quite a, it's a less obvious conclusion than just like, oh, I can split my animal type into dogs, cats, rabbits, birds. It's saying whenever you see an if in your code base, it's an indication that maybe there exists a nice splitting of your type into smaller sections so that you can handle them one at a time. The inverse of this is also true. Nope, that's not what I want to say. That was just what was written at the top. No, it wasn't. Okay. If an if statement is just a way of combining 2 functions into one, which means if you do have an if statement, you need to provide me, if I'm like one of your colleagues, with a reasonable sort of reason for combining these 2 functions that were very easy to handle at the time into one big function that is more difficult to handle. And it also means that all of these other things like inheritance, nullables, like monads, polymorphic functions, pattern matching, switch statements, guard clauses, they're all examples of ifs, and they are all prone to the same technical debt that you get when you interact with if statements up here. And so this is probably the major takeaway, is that if you see an if statement in your code, check whether you can split it into multiple types. See whether it's a reasonable splitting, because you'll find that you'll be able to look at smaller segments. But as I said earlier, there are some follow-up issues, and I imagine many of you are thinking of this at the moment, is that we have this, I've only been considering a very small section of my problem, like my sort of program. And if I zoom all the way up, Essentially what's happening is a user is clicking a button on a computer and it's creating a visual output. There are some ones and zeros, they're turning into other ones and zeros. Like you're sending a HTML request to somebody, or you're receiving a HTML request and it's outputting a HTML response. So if this is a single type, how do I then split it into multiple types? Don't I have to use an if statement to split it into multiple types? And the answer is yes, you do. So if you look at this code over here, you'll notice that, hey, actually, this possible double, it's just got an if statement under the hood. Same with, like, I don't know. I actually don't have any other examples of that. But the point is that the if statements still exist. They haven't really gone away. They've just been moved to the front of the application. Have I really gained anything? And the answer is yes, you've gained a lot, because you have to be able to differentiate between functions that are very easy to deal with, these very simple mapping functions that don't grow as your application grows, and the functions that actually hold all of the functionality within your application. These functions are really like going to grow and grow and grow and grow and grow, and if you split out the if statements into these mapping functions, you end up with a lot more sort of manageable circumstances where you don't have to deal with shit code. The other thing you might notice is that actually there is some advantage to sometimes joining your functions together into union types. And you've also noticed that, hey, actually this code does have this thing called a weighted animal, which appears to be some sort of abstraction which unifies multiple different animals. But the thing is, these abstract types are very, very simple and don't have very many fields. And so they're much easier to operate on because you don't have to handle all of the different possibilities. And you can see that the actual function that uses, that gives us the common logic is actually very, very simple. So what you have to do is you have to differentiate between types that you've defined as a union between sets and types that you've defined to be an abstraction that all animals have. So like these animals all have a weight, so we give that a weight, and then we give it common logic. We use common logic for this weighted animal type. But this union type here only really has mapping functions attached to it because we don't want to use a lot of logic on them because it's very difficult to rationalize about our code base if our code base grows. And so it's kind of hard to do a union type in C#. This is kind of how F# compiles over to C#, where essentially you just have a constructor. You just have a whole, you have public constructors for each like subset of your union. And so, but this is how it could be done, essentially. I just thought I'd show an example. And that tends to be like a distinction that you need to be able to determine to like actually evaluate whether if statements are good or bad in your code. The second thing you might notice is that you have a lot of CRUD applications where you're mutating state for your dog or your cat or your rat, and it's just much easier to write that in one function as an animal to an animal. And this is an issue that is somewhat close to solvable if we just use a class that like if we just have a public getter and setter, which translates us to this subset so that now we can just call, I've written it up here. Like we can have this function grow and grow and grow, and the mutation of our individual classes doesn't change that much. Because this code here doesn't grow, this code here grows, but it's the common logic. So you don't actually have this sort of problem of, hey, I need to write the function 6 times because I have 6 different like subsets within my set. But the issue is that this only goes 1 layer deep. This solution will only allow you to get from dog to weighted animal, have some function here that you can use and translate it up to dog and also cat and also rat. If you want to go 2 layers deep, it becomes impossible to do it this way. And so the keyword that you need to learn is lenses if you ever run into this problem. I can go over the sort of vague details of it, but essentially a lens is just a weird way of defining a getter and a setter. And you can use then you can define the getters or setters this way, and then you can run your function by just, this code is over here, by just using the lens and calling this update function defined generically up here to then update your individual classes. And this allows you to go infinitely many layers deep in this sense here. And there's actually quite a lot of extra cool things that lenses can do, but I won't go into them at the moment. At the moment, probably the key term is just when you run into a situation like this, just Google the term lenses. There are some libraries out there that automatically do it for you. So the final question, so those tend to be, lenses provide a solution to pretty much all of the, and union types provide a solution to all of the follow-up problems that you will run into when you're splitting your if statement into multiple parts. But you still need to evaluate whether it's worth removing your if statements at all. So for example, in this code back here, actually, I still have a ternary operator here. It didn't seem worthwhile to me to remove this. It didn't seem worthwhile for me to remove this switch statement over here. And I sort of started off this thing being like, oh, well, I dislike design patterns because you get this answer of it depends, it depends, it depends, it depends. And so I'd like to just end this talk with a hard and fast rule of when you should probably remove your if statements. And this is the idea that your function, the input of your function is what the function accepts. It's its usefulness, the options that you can use it for. And the output of a function is what it does. And so the more options for the output of the function, the more possibilities you have to consider when looking at the function from the outside. And so the hard and fast rule I have is it's worth it to remove the if it reduces the size of the output set of the function to a type that already exists in your code base. Because this is saying, hey, I've already defined, I've already decided that this type exists and is useful. Therefore, refactoring my function into smaller functions so that I can get an output that uses this type will then be useful for me. You've already made the decision that the subtype is useful. So some examples of this are invalid state. So if you see a nullable, then if you can refactor your function so it doesn't return a nullable or doesn't return a result, doesn't return an option, then it's almost always worth splitting the input type into multiple types to avoid having to return that type. If you have situations where you have a nullable within the output, so for example, this thing over here, if you remember, this nullable output here, it's worthwhile to turn that into a function that just, turn that into a function that outputs it only when necessary. And if there's some sort of obvious common concept, in this case a puppy, it can be worth it. So in this case, we have this idea of desexing a dog, and it turns out that it is marked with an asterisk if it's over. So if it's an adult dog, then it costs more. So maybe it's worthwhile defining this distinction between an adult dog and a puppy, but honestly, take it or leave it. It depends on if you're depends on the time span of your project and stuff like that. And so those are what I consider the answers to these 4 questions. The general takeaways are I probably should have looked at this before I did the talk. What does my function look like from the, to evaluate technical debt, you should be able to think of your function and see what it looks like from the outside. Larger types mean that you have to think about more possibilities. And if is just a joining of 2 functions together. You want to differentiate between the functions that are big, fat, functionality and the ones that are thin mapping functions. And if you actually do try to implement these solutions, you might run into some problems, and they are often solved by either lenses or union types. And that's, the entire talk. So. Yeah.
I've got a question here from Paul. Is there any performance considerations you need to be careful of removing the ifs and replacing them with something else, so like more function calls?
The vast majority of applications don't run into performance issues. You're essentially looking at like a 0.01%, like 0.0001, like second operation that ends up taking a little bit longer, like 1% longer, and you don't, like, no user notices it. In general, the situation is usually that you have a large amount of code, and that code, like 1% or 5% of that code is what is responsible for your performance hit. So the issue of, hey, this might cause some performance issues, it's actually much, much better to have your function split into this situation so that you can identify the 5% of the code that actually needs to be optimized to solve the performance hit. So in general, when you start off a project, it seems to be a lot better to just like try to optimize for code cleanliness so that when you do run into the performance problems, you can find that area and then just solve it immediately.
Yeah, he was thinking right down to the opcode level, and sort of jumps versus popping on the stack and popping off the stack, that kind of.
I think, so there's a guy who works in Rust. So I think the way you can, there are constructs that are, I think lenses will allow you to like write it in such a way that you can actually write very low level code on the outer layer for your persistence. It's either lenses or monads without having to worry about it. Like a performance, like without sacrificing the sort of ability to split your type into multiple like smaller types.
Yeah, I guess it'd be also interesting whether the compiler can inline some things as well.
Yeah, like you're thinking like spans or like the introduction of spans and stuff, and you.
Just with an optimizing compiler might realise that it might just inline the function call rather than having it as a call sometimes.
Yeah. So I'm sure there's a lot of situations where your code that doesn't really impact your performance will be slightly faster. And I think that, like, obviously when what's happening here is all of this code is creating a new copy of a dog every single time I want to mutate the state of the dog. But the thing is that it's just completely negligible in the grand scheme of like your actual program, and that's not the type of code that's going to end up giving you a performance hit. Yeah, it's quite a large like philosophical debate, but it's my opinion is that like some of the most performance code in the world is written with this type of style where you're essentially duplicating and trying to make it so that like you can segregate off the 99% of the code that you don't need to optimize so that you can work on the 1% that does need to be optimized. Yep.
So to me this seems almost like we're just pushing those if conditions further up the
Correct.
chain of the, I'm
Yeah.
going to use a web request, then at the request.
Yeah.
So where does the benefit of splitting it into different classes rather than just dividing the function into a bunch of sub-functions? So you do the first function call that does your first layer of if statements. So if dog, then perform get dog weight. If cat, then perform get cat weight. Is there a difference between just pushing the ifs further up?
So I.
So for the people online,
Sorry. Yeah, you go. Sorry.
So just for the benefit of the people online, so the question is, if you're pushing the ifs, like, does they go away? Is that the kind of question you're asking, or?
It's more of a, what's the benefit of using separate classes as opposed to just separating out your ifs into function calls?
Okay, so the question is, what's the benefit of separating into separate classes versus just separate function calls?
Yeah. So I believe maybe just for me to try to understand this conversation, would you say that this code is representing your suggestion?
So that code is it has a bunch of ifs in there.
Yep.
So
is...
You would replace this with a series of calls that are get dog weight, get cat weight, based on the animal type. So basically, replace this with a switch
So
on animal type.
So I guess the issue is just that when you look at these functions from the outside, sorry, that was not what I was looking at. That when you do that, this function still will look the same on the outside, right? So if I ever want to look at my get vaccination bill function, I'm calling this function, or some functions calling this function up here, they do still need to go into the details of all of the individual things to work out what happened. Let me think whether there's... you end up in the situation where you're still defining these output types here as well, where there are some output types where you don't really know whether you care or not about it. You have for example, also if you have a new developer and you're trying to implement a feature for rats, right? There's all of these fields on here. It's going to keep on growing and growing and growing. How does the new developer know whether the rat needs a weight or gender or whatever? Is it going to have to go into all of the this is not going to be the only function in the code base that uses animal, right? So you have to go through all of those different functions, find all of the different if statements, figure out which of these if statements are relevant to the rat and which are not. When you have it explicitly defined as a type, it becomes very, very easy for the new developer to look in and be like, oh, this is all I need to know about the rat, and it's nothing.
So that's what you're referring to when you're looking at the scope of what can be output from a function.
Yeah.
I had a question or comment from Ian in the chat, which says the 3 database tables maintained by vet administrator, animal types, specific animals, procedures with attributes, including values, would reduce the ifs. Never have reference to dogs, cats, etc. Only animal type functions.
Sorry, that was a little bit complicated for me.
Yes.
3 data tables maintained by vet administrator, animal type, specific animals, procedures with attributes. By vet administrator, animal type, specific animals, procedures with attributes, including values, would reduce the if. Including values.
Maybe Ian, if you maybe add a bit of extra context just to
reference to dogs, cats.
Anyone else in the room got some questions?
Yeah, if you could just write very, very short sample code or a little bit of an elaboration on the question, sorry. Children.
That's okay. So Calvin, is this something you've used yourself in practice?
Yeah, I mean, so the thing is that, in general, it's more of a framework for viewing individual sections of code. But I have it's actually quite easy in your current code bases to look at situations where something returns a nullable and you can just reduce the input type. So I mean, at work it happens fairly frequently where you just look through and you're like, oh, okay, actually, if you just change the input type of the function, then you don't have to deal with all of the sort of follow-on of checking the output type for what the output was. But also, in general, once you sort of start to view things in this way, where you're just constantly asking the question of what my function looks like from the outside, you end up just sort of doing a lot of this type of stuff naturally. So I can see whether I have anything here.
I'm curious if
I
people...
love how you have a folder in your documents called murder.
Wasn't my idea. Was a friend friend named the repository.
I'm curious that people in the room, does this make sense, or is it obvious, or has it gone over your heads, or are you trying to figure out like where would I use this, or what's the reactions for people who've seen it?
So,
Sorry, I'm just going to say, it almost seems to be saying, well, we should use object-oriented designs, but haven't we been doing that for like 30 years?
well,
Um,
maybe the abstractions are actually just another form of if, right? As opposed to like the union types,
Yeah.
I think is the
I
difference
guess
here.
the key is the union types, which may be like something that's got interfaces or traits or something.
I guess so the I would view this more as functional design than object-oriented design. One of the things is that we're currently looking at like object-oriented has a lot of like pairing of type, like your types to your functions, super duper heavily. I guess the way to view it is if you have your object-oriented situation here. Sorry, let me think about this for a second.
And I guess your traditional object-oriented would be to have like a type hierarchy where you have an animal and then a dog that inherits from animal and a cat that inherits from animal.
Yeah. In this scenario, rat kind of throws that one through a loop.
Yeah, and a rat, or is a rat and a mouse, are they is
Well,
one?
it means you can't have any, because they have no properties, it means you can't actually have any properties in the base animal class.
Yeah.
Yeah.
Or you have to have nullable properties, I suppose.
Which becomes the same problem that they're trying to solve in the first place.
Um,
I guess, well, my sort of seeing the talk tonight, it does make me think it's putting more of a focus on types and classes, whereas I guess traditionally you might not have made so much use of that, so maybe there's part of that really.
Yeah, I'm just trying to think of, I know like, so it's very hard to come up with like an example on the fly, but generally what happens is that you essentially, when you're doing this type of situation where you're doing it in an object-oriented way, the issue becomes that when your boundaries change, it becomes very, very hard for you to like actually do some cross-references like this. But it's very, I'd need to write some code to actually explain the point, because it's very easy to be like, oh, that's a problem with this type of design, but it is different. I guess the thing is that like, my claim would then just be, if you have good object-oriented design, you probably won't see very many if statements in your code, so you probably won't be asking yourself, how do I get rid of my ifs, because they just don't exist, would be the best answer I can give.
How can we get rid of ifs that are inherent in the problem domain?
Such as, sorry, I shouldn't ask for.
Like, if you have a business requirement that is a choice between two things, how do you fundamentally get rid of the if?
So you pull the if towards the front of the application.
So you're shifting it.
Correct.
So have you got an example of that in the code there?
I think the code there is a little bit
I was trying
gross.
to get that one. I think that's actually kind of similar to my question in a way. It's just shifting that if further forwards.
Yeah.
The distinction is that by shifting it, we are technically doing that, but we're also dividing into types. So what that does is that forces, rather than big function and also little functions that have to all operate in that same domain, it forces the functions to be small and only focus on their one domain. So in this case, rather than one, it was the function just focuses on this dog type or this cat type. And we have to do the if earlier to split the input into the appropriate type, but it means that function is far simpler and far more maintainable.
So
Like,
the,
trying to get that?
yeah, I think that's roughly my point, is that when you have the if statements at the front of your, like at the entry point to your application, all of this becomes a lot simpler, and this is the stuff that ends up growing exponentially. So if you have your if statements in here, you end up with large amounts of complications. I think probably the simplest example would be like this positive double sort of situation. If you don't have this positive double type, how do you, what you have to do is you have to check the weight at every single opportunity, right? Because essentially what, and so this is just one check. It's only the check when you are passing it into the double type. But in the case where you don't have this positive double and you have some negatives and you're representing the weights with negative numbers, you're suddenly like, oh shit, like I needed to check, like if I forget one of those if statements in any of this code over here, right, I'm going to end up with, far out, I can't double click apparently. I'm just gonna end up with bugs, right? So anything that uses the weight, right, anything that uses the property suddenly has to consider both failures and successes, which means instead of just one spot, you have to consider it in every single point where you're using the property, if that makes sense. Maybe it doesn't make sense.
Ian came back and basically said that the base price function, he felt that shouldn't be in code. That's something that might need to change a lot.
Should never be in code. So
I guess
the suggestion is to copy and paste.
Should be a configurable value.
constant, yeah.
I think that's an example of that.
Well, this particular vet practice, their prices are very fixed. So
Yeah, inflation's definitely never going to happen.
no, yeah, it's fine.
So you're saying this should be a,
I think maybe Ian's suggesting
split out this $100 into a separate constant,
might
and then,
need to be a database lookup or something rather than just hard coded like that.
oh, okay, sure.
This is sample code, so
Yeah.
I think that's just a clever demo code.
Yeah.
That you hard code a lot of stuff you normally wouldn't.
Yeah.
Any other questions for Calvin? Ryan, yep, go for it.
So I actually have one around the second purpose of this, which is to help with onboarding. At what point do introducing new patterns, such as the whole lensing pattern, what point does that make it more complicated to onboard someone versus the problem you're solving?
So yeah, there are issues with specifically the lens pattern where it is quite complicated. It's sort of a concept that you have to learn, or hire for. It's something, essentially what it is that you have this idea of a whole lot of fundamentals that don't change. Where am I? There we are. Like we have a whole lot of fundamentals that don't change, and this is one of those things that don't change between, no matter what domain you're in, a lens is still a useful construct, and so you can kind of just hire for it, essentially. And it's actually, I mean, you could probably explain it to a new developer in like maybe 20 minutes. It's essentially just, this update is pretty much the main thing. It takes in a function. Essentially it does this, right? It takes this like the function that you want, have, and turns it into the function that you want. So this is the function that you have, and like this over here is the function that you want, if that makes sense. And so all it does is just like runs the get, like runs the function on the value that you've gotten, gets the new value, and then sets the value afterwards, right?
So it's just a pattern you've just got to learn once in order to be able to
Yeah.
use.
But you can use it not only, but you can use it not only in your own project, but also just like every single other project that you then work on. So it's a little bit different from like knowing that, you know, cats don't have wings or something equivalent. Whereas like that's only specific to your domain. Yeah, I mean the other thing, yeah, I feel like that's also a lot easier to intuit than just like you have this giant sort of system where there's a whole lot of things that like you only really remember as the experienced dev, you only really remember it as you're going through the code. And so it's just like, you can't give people warnings about it, right? You can very easily just be like, hey, this is something that you'll see throughout the code. It means this, a lot easier.
All right, we might wrap up there. If there's anyone's still got a question online, we'll leave the chat open and we can come back to that. But the pizzas are here for the people in the room. People at home, I hope you organise your own pizzas. But if you'd like to thank Calvin for the talk tonight.
Yeah.